Hello, everybody. I recognize some faces. Thanks for coming out. So I'm Nick. This is Christian.
Hello.
We've got 150 slides, and we've started late. So buckle up.
Tuck in.
Yeah, so I'm Nick. This is Christian. And as Kai introduced us, I'm head of design at X, and Christian works alongside me as design lead. This is X. This is our CEO. X is a moonshot factory. It's a place where we try and make big bets and use breakthrough technologies to hopefully make big changes to make the world a radically better place. We're probably best known for this project. This is Waymo, the self-driving car. We're sort of pioneers in this field. And this is designed to address the 40,000 people that die every year in the US on the roads, 90% of which are caused by human error. This is another project in testing. This is Loon. It sort of addresses the billions of people that can't access the internet around the world. This is a launch facility in Winnemucca in Nevada. This project really exemplifies some of the things that we like to do at X, which is think laterally and use technology to solve big problems in kind of unexpected ways and deliver service to people that really makes a difference. This is a more recent project. This is the Everyday Robots project. And this is very sort of thematic of what we're talking about today. This is designed to make robotics work in messy, unstructured spaces, as opposed to programmatically following something by rote. So my background is, as you heard, Kai said, I'm an industrial designer by training, but I've been in the role of sort of futurist and working in the emerging technologies space for quite a while. I'm also a partner at the Near Future Laboratory. Hopefully somebody knows the Near Future Laboratory. Anybody? Oh, there's one there. Great. Woo! So yeah, we work in the field of design fiction. We pioneered this approach to telling stories about the future in very kind of graspable, grappleable ways.
Yeah, and I'm Christian. My background's in architecture and interaction design, like Kai mentioned. Also speculative design, and primarily developing novel applications for emerging technologies. So X is kind of a perfect place. This is the Museum of the Future in Dubai from a previous role at Tellart. And as already demonstrated, we know two-person talks can be kind of tricky. It's why you don't see a whole lot of them. But we're going to give it a shot. You know, I'm going to try it out. And it's going to be OK.
We'll hope it's be OK. Let's see.
Well, hopefully it'll be OK.
Please burn the tapes if it's not. So design is messy. We talked to Kai nearly a year ago about coming to do one of these talks, and we're really happy to be here tonight. It's just taken a while to schedule. But one of the first topics we wanted to talk about is messy. And it just came to us kind of naturally, maybe as a result of the kind of audacious, long-term, complicated projects that we do at X, but also just felt like something we believe in. And we're at the sort of moment in time, we've just hit 2020. We like round numbers. Round numbers are good. It starts you thinking about, like, where have we been? Where are we going next? It's kind of this overlap moment. And just starting to think about the state of the world. We want to just sort of zoom out of design for a bit. You know, we do our work in the world. The world has its own character, its own grain. And so what do we think the world is like right now? I've been watching a show called The Morning Show on Apple TV. And there's a phrase that came from Billy Crudup's character, Corey Ellison, who's this kind of sleazy business sort of executive character. And the phrase is this, which is chaos is the new cocaine. It feels like chaos, messiness, ambiguity is becoming an increasing part of our lives. It feels like it's here, it's everywhere. It's like this big part of what we do every day. And just digging into that a little bit, you know, global politics is chaotic. It really is chaotic. Whether it's worse or better than it was in the past, it really feels that way right now. The notion of poverties and inequalities and injustices and marginalizations is a big part of what we talk about in global politics. And some of that is just symptomatic of the way the world is moving, but some of it is intentional. So I don't know how many of you know this chap. He's Valery Gerasimov, and he's Vladimir Putin's chief military strategist. And he has the Gerasimov Doctrine, which is a willful use of disinformation to spread chaos for strategic effect. It's a willful adding of chaos and messiness to the world. We're also surrounded by incredibly messy and complicated things, complicated systems, complicated services. 40% of the food in the USA never makes it to your table. That is a huge amount of waste, and it's symptomatic of an incredibly complicated and messy world. That actually costs $165 billion a year. We're also seeing like overlapping issues between two different systems. So the system of where we live and the system of how we make things and consume energy are overlapping to the point where 9 out of 10 people live in places where the breathing quality is below what the WHO would recommend. This is the outputs of one system having a huge impact on the other system. And the big elephant in the room is climate change, the ultimate intractable problem, it seems. It seems like there's so many moving parts, so many disconnected drivers. The world is literally on fire, and yet we can't figure out what to do. It's not just Australia, but Brazil and up the hill from where we are now. Now, some of this could just be part and parcel of living on Earth. It could also be part and parcel of the amount of time we spend online. There's a theory about the Enlightenment that if we just get a lot more information, we can make sense of the world. But we've got a lot of information, and we spend a lot of time consuming it. But it seems like actually things are getting more confusing and more complex and more messy. It seems like this is a difficult thing for us to understand and difficult thing to move forward with, but this is not necessarily anything new.
Yeah, it's fair to say this isn't new at all. This is probably what generations upon generations have felt. The advent of the telegraph was probably horrifying to some. But in particular, something comes to mind from the late 80s. So this term VUCA that the US military started using in their management training for military officers, essentially, to describe the kind of new nonlinear dynamics that they were seeing in the battlefield. And VUCA is an acronym. It stands for volatility, uncertainty, complexity, and ambiguity. It's essentially a structured definition of chaos. And what I find so fascinating about this is yes, this is this concept from the kind of war zone, but that it resonated with the business community and with academia and has been adopted as a kind of framework for talking about our global economy and our society at large. So we've been kind of mapping this nonlinear volatility, uncertainty, complexity, and ambiguity framework onto the way that we think about the way that we live in 2020. This is a lot of text to throw on a slide. I'll let you kind of sit with it. But this is what William Gibson's character in pattern recognition meant when he said that fully formed visions of the future aren't available to us in a chaotic present. So we have no future because our present is too volatile. There's insufficient now to stand on. And I think this is a kind of a critical problem for designers because it's core to our role to understand the world and make intentional, responsible decisions. And in a state of chaos, how can we reasonably do that? So that's part of what we want to talk about today. So in a context of tremendous messiness, what is our role? And we want to highlight some of, I think, the shortcomings that we've displayed as a discipline, and ideally propose a new disposition for design, or at least have a conversation about what a new disposition might look like that responds more intentionally to this state of messiness. So also to acknowledge we don't have all the answers, obviously. It's not like we have some privileged position at X that gives us answers here. But I think by virtue of working on these very highly ambiguous, very long time frame projects, I think it gives us some ideas to kind of start a conversation with. So what is an appropriate response to messiness, and what are some tactics for engaging with it? So the first is kind of the obvious one, just ignore it, and draw a kind of boundary around a space that we feel comfortable kind of controlling completely. No reason to pick on Kareem Rashid in particular. I could have picked any image here, but it's a fairly familiar model to all of us. This is the model of the kind of hero designer or starchitect. I don't know about you, but this is how I was taught in school. This is maybe a kind of legacy of the apprenticeship tradition of design, where we can revere the master mentor. But it's a world of idiosyncratic artistic gestures from the heroic creative individual, who through their expressive sketch can impose their will on any problem and define a complete and harmonious world of their own creation. So in this world, design is kind of argued on the basis of individual charisma, the novelty of vision, and maybe celebrated for its technical mastery. And I think it's also worth acknowledging that this is high art, right? This is the kind of triumphant expression of human ability. Gesamtkunstwerk. Thank you. Does anyone remember this from your design or art history education? So this notion of a complete and harmonious world, like Gesamtkunstwerk work means like a total design or a total artwork. And as Mark Wigley says, it's where design takes over a space entirely and subjecting every detail, every surface to an overarching vision. So essentially, a Gesamtkunstwerk is a closed world. And it's beautiful, and it's a tremendous and complete attention to detail and to its internal self-consistency. But you can think of a closed world kind of like a space colony or something, right? Where the interior has every detail accounted for, every system kind of connected and prepared for, but beyond the bounds of its world, everything is ignored. And I mean, in one framing, you can kind of think of any modern consumer object as a kind of closed world, or at least interpret it that way, where there's a tremendous attention to detail. It's self-consistent, it's complete, and generally speaking, acknowledged as high design because of its perfection. Essentially, everything is optimized and in its right place. Essentially. However, this is your role.
Yeah, this is it. I think we've split these up into Christian sets it up, and I come down with the bricks. I think that maybe mirrors our character a little bit. But however, so yeah, if you ignore the complexity, you wall off the externalities and the external things that are involved in what you're doing. And Mark Wigley, who Christian referenced, it's a fantasy. It's a fantasy about control. It's a fantasy about saying, this is all mine, and I'm going to design this thing, and I'm going to ignore everything outside of it. It's just my domain. This is what we're going to do here, and it doesn't matter what happens outside of it. But the truth is, what happens beyond the bounds of your closed system affects it and is affected by it. There's no such thing as a wall. There's no such thing as a boundary. A Gesamtkunstwerk nice. Is not a real thing. The building that you've made as a single art, work of art exists in a space. It exists at the end of a road with neighbors and other things. And just as a way of sort of bringing it up to maybe a contemporary audience, take a simple product like this. This is the Amazon Echo Dot. It's a simple product made primarily of polymer and a bit of metal in there, some paint, a little bit of circuitry, some radios. It's very cheap. This is an $18 product. It's a very, very cheap product. And it feels like it's a very simple thing. It feels like, yeah, this is a product I buy and I use and it's fine. I talk to it and it delivers services to me. But a project done by Kate Crawford and Vladan Joler in 2018 really started to dig into what you're buying and what you're interacting with when you have this product in your life. And they made a map, the anatomy of an AI system. So this is actually not the full system, I believe. There's plenty more than this. But what it does is it looks at dependencies, it looks at interconnections, it looks at externalities of the system as it's made. And I'll just zoom in a little bit on a couple of areas. There's all the raw material, there's all the supply chain. Where does the material come from? Who are the companies who are supplying this material and forging it and refining it and delivering it? That's a whole lot of stuff to think about, even if you're just thinking about this $18 thing. You've got the back end and all the network services, all the AWS has to work, or this product is nothing, it doesn't exist. You've got all the data management, people's privacy, people's content. You have to really concentrate on this stuff too. That all needs working out, that all needs figuring out to make the $18 product work. Likewise, the physicality of the product, it exists, it needs shipping, it needs collecting. If you recycle it, what happens to the recycled materials? All that stuff is all embedded and within the $18 product. But because we just work with the $18 product, we don't really see it. But it doesn't mean it's not there and doesn't need consideration and actually doesn't need designing. And this leads us into kind of actor network theory, which put very simply is a way of very complicated things have a way of appearing to us as very, very simple things. Like a TV is sort of a box on the wall and a device you hold to make it do things. And it only sort of reveals the networks and the complexity behind it, particularly when it breaks. So when a TV breaks, yes, you've got mechanical breakage and you might need to, I don't know if people mend TVs anymore, but if you can mend a TV, you're switching out resistors or doing that kind of thing. But increasingly, the login doesn't work anymore, the password doesn't work, the network's down, whatever it is. The system gets bigger and bigger and bigger. And that can be a TV, it could be a financial system, something of that scale. It could even be the internet. We don't see the extent of the network until it breaks or until we're confronted by its failures. And I think generally what I'm trying to say is we're still thinking about the design of these products, like these $18 products, like they do have a boundary around them, like a hammer. There's nothing complex about a hammer. I don't need a login. But the world of the objects that we're building now is not the world of hammers. We're building complex things. One thing I want to talk about as well is this notion of building a very simplistic boundary around what we're trying to solve leads to a notion of solutionism, that we can kind of determine a task, do the design work, and finish up. But I want to introduce a term that we've been using a little bit, which is solution entropy, which is this notion that we never really solve anything. We might break down a big problem into smaller problems, or we might even kick the problem down the road a bit, or kick it into different companies, or help sort of reduce it down into its smaller parts, but it never really goes away. This is a term that we've used a little bit. I'd like you to use a lot. But I think it really helps you get out of that mindset of thinking, somebody set me a task. You know, I learned design as a problem-solving exercise, like a plumber or something. You know, you have a leak, I put a patch on, we're fixed, done. But I think this quote by Paul Virilio is quite interesting here, and most people just use the first line, which is, when you invent the ship, you also invent the shipwreck. There were no shipwrecks in a world before the ship was invented. And I think we have to start addressing the fact that when we think we're solving something, what we're actually doing is breaking down a bigger problem into smaller problems, or punting it somewhere else. So when you invent USB-C, you invent dongles. Like this is... USB-C is undoubtedly a good protocol, a useful connector, but you also then have to deal with all of the other things. The problem is not solved, it's changed. Likewise, the half-dog. Who knows the half-dog? So the half-dog is an artifact that happens when a fast-moving object, in this case, Labrador, moves through a panoramic stitched image, you know, when you move your phone across. The dog runs very quickly through it. The algorithm doesn't understand that movement, so it stitches them together, and you end up with a half-dog. So panoramic stitching is amazing technology, like life-changingly important, complex technology. And yet we never struggled with half-dogs before it existed. So there are no neat solutions. Just really, we need to stop thinking like that. And just to sort of wrap this up and really nail it in, there's this notion of what we do has a beginning, middle, and end. The brief, the design bit, the delivery, and then you charge for it, I guess. But the truth is it's all middle. It's all middle. There is no end. You start something, and then you have to keep doing it. There's just more design to be done.
All right, so we're on to tactic 2. Don't worry, there are only 100 of these. OK, so you can ignore it. You can put a wall around it. Kind of, what else can you do? We can simplify the mess. So this is something that we all do intuitively. The human mind is an incredible abstraction machine. So we intuitively form abstractions through the use of symbols, metaphors, kind of other representations of concepts. You know this. You do it every day. You're doing it right now. But then we also form abstractions around things like the cloud, which compresses a tremendous amount of complexity into a discrete concept. And then the messy interior within these boundaries kind of disappears, and it's translated into a manipulable object that you can then use in a diagram to talk about all the other things you're making that connect to the cloud. So we make models for the organization of incredibly messy and dynamic realities in order to understand them and to act responsibly on them. This is the so-called rational model of design. And it's, again, incredibly useful. It helps us understand complexity, build mental models that we can use to make this complexity workable and manipulable, right? But this is the kind of built environment as a kind of diagram, right? This is the expression of interior organization in the final form of a thing. This is OMA's Seattle Public Library, the diagram on one side, the building on the other. And in its extreme, this approach leads to a kind of extreme minimalism, right? So Dithering saying famously, as little design as possible. The world of a system stripped down to its absolute kind of simplest components, beautiful, orderly, generally speaking, very usable, and decidedly unmessy. It's also the world of design language systems, components and patterns that are repeatable and make the work of highly distributed multidisciplinary teams manageable. But it also makes the kind of user experience of these things predictable and familiar. So I can reasonably expect that, you know, when I tap on that round thing, something is going to happen. But this desire to simplify kind of carries through in our aesthetic choices. So the designed world becomes a kind of post-embellishment world. And this aim for a kind of total efficiency, cleanliness, optimization, abstraction also carries over into our design processes. So I'm going to jump back to history for a second. This is Frank and Lillian Gilbreth's work on time and motion studies. So they were basically looking at how to optimize human activities in a number of key tasks. So manufacturing objects in an assembly line, kind of common tasks in the kitchen. They studied bricklayers and all of their kind of sequences of motions in order to figure out how to improve them. And they built a library of abstracted actions, which are called thurbligs, which is almost Gilbreth backwards. But there are these 18 elemental motions that could be described in a logical sequence. They could be timed and then rearranged and kind of optimized. So translating the kind of fluid, continuous, and somewhat idiosyncratic movement of individual people doing individual kind of approaches to the tasks they'd learned over time into these kind of structured and logical sequences. And when we apply this abstracted model to design and our own process as a discipline, we end up with a kind of generic process that can be brought to bear on any problem that we face. So this is kind of intriguingly, this is an Eames video from 1964 at the IBM Pavilion of the World's Fair, trying to explain how computers work to the general population by using the metaphor of how humans solve problems. So computers work just like humans do. So let's explain how humans work. So there's a lot of metaphor here, but I think it's kind of interesting. So the first step is stating the problem. The second step is collecting information. The third is abstracting information. And the fourth is building the model of this information, or of this abstracted map of information. So in doing so, we build this kind of representation of reality that clarifies all of the mess and turn it into something that's logical and manipulable, kind of like the Gilbreths. And then finally, you intervene. So you manipulate this system, you manipulate the model. But I think what's interesting about the video is they end the sequence here. So the method used in solving even the most complicated problems is essentially the same method we all use daily. So this is a kind of replicable and generalizable problem-solving process that can be applied to anything from urban planning to planning a dinner party, which is the example that they use after this. But this should look familiar to us, right? This is the kind of sequence of actions that we're taught is the design process. So this is the Design Council double diamond, kind of universal design method that goes through discover, expansive, define, contractive, develop, expansive, deliver, contractive again. And fantastic agencies like IDEO use in describing the design thinking process and the steps to go from a kind of problem understanding to prototyping and kind of solution delivery. And I think what's interesting about this model is that it introduces some variability at the end. That's where the iteration happens. But essentially, it's still a rational and linear process that ingests messy problems on one end and kind of spits out clean solutions on the other. So yeah, that's tactic number 2, which is to find mechanisms for simplifying, organizing, and essentially processifying mess.
However. These tools are useful. This is how we learn, right? These are very, very useful things for us to understand. It's very hard to have someone walk in a room and say, right, I'm going to tell you this incredibly complicated thing. Simplifying things down is the way that we learn. It's how we teach, it's how we learn. They're very useful as pedagogic tools, but the issue comes when that pedagogic tool, when you've ingested the sort of bare bones of the process or the concept, when you try and reapply it back into the messiness. Because what happens is, and what happened with all these models is, it might be good for sort of a TED talk to say, this is what design is, but actually then somebody takes that and tries to implement it. This sort of thing starts happening. People go on Twitter and they say, I think there should be another diamond, or there should be a feedback loop here, or maybe another hexagon, or actually I tried this and what we found was, and all it is just reflecting the complexity that was ignored in the simplification process. So you end up back in these kind of more iterative feedback loops. This is another person's attempt at making the design thinking process more real. And you can do this ad infinitum until you end up back at the messy. Until you end up at something like this. So this is Deloitte, their agile landscape, and you can see design thinking comes in on the left. But the point that we're making here is not to make fun of Deloitte. They're trying to make sense of an incredibly complicated thing, but in trying to include the complexity, they've ended back at complex again. We're still in messy, and this is, I don't know how usable this is for a new product or an innovation project. it sort of becomes a little farcical at times. Interestingly, the D School, who are sort of the exponents of design thinking, recently announced that they're not going to use their hexagons anymore because over time they've realized that this complexity is unavoidable and, quote unquote, design isn't a process, which is, sort of fascinating to me. Christian also mentioned metaphors. Metaphors are a good way to help understand complicated things in a nice packaged concept. The issue with metaphors is they're arbitrary and they're based heavily on your previous experience, where you come from, the language you know, the people you've interacted with. Those different things that we use, say, oh, it's just like that. If you haven't experienced that in the same way as Christian and I have, then the metaphor is meaningless. James Bridle, the artist and brilliant writer, has a good line in metaphor, but his argument is, the cloud is not some magical faraway place made of water vapor and radio waves where everything just works. And Timo Arnal, brilliant photographer and designer, started to take pictures of the cloud. This is the cloud, or at least part of it. It's real. It's full of computers and cables and private servers and power supplies and other things. The cloud is not the right metaphor. I'm going to hand that over to Christian. You can do the summing.
Again, you can simplify the mess, you can organize it, you can processify it. Tactic number 3 is to map the mess and to essentially know it entirely. So you kind of acknowledge that complexity and messiness exist, but your response to it is to know it absolutely and quantitatively. So again, I'll go back to history. Could have picked a lot of examples here, but chose Norbert Wiener, the founder of the field of cybernetics. And he was interested in self-organizing and self-regulating systems, and it kind of invented the concept of feedback loops. And then Jay Forrester, who was also at MIT around the time, kind of 50s, 60s, founded the field of system dynamics, which tried to model nonlinear systems using feedback loops. And this all coincided with the kind of heydays of the birth of large-scale computing. So there was this fundamental belief that even the most complex system, so the global economy, a city, the human body, could be abstracted, modeled, again, quantitatively, and simulated in a computer. Even the planet. So this is Jay Forrester's World 2 model. It's a computer simulation of interactions between kind of key components of the planet, so population growth, industrial growth, food production, limits in the kind of ecosystems of the Earth, to try to understand what the carrying capacity of the planet was. It was then updated in the World 3 model by Dennis Meadows for the Club of Rome, which some of you maybe heard of, the kind of famous limits to growth model or project. And it's actually it's a system of systems. I thought we could go through a few of them. There are a few different sections on the map. So the first is the non-renewable resources system, the industrial system, which has things like jobs per capita, the pollution system, that funny little cloud thing. I'm not sure if that's pollution or not, but I do like it. And then here in the food system, you see things like agriculture production, land use, allocation, that kind of thing. But I thought we might spend a little bit of time with the population system specifically. And if we zoom in here, you can start to see what some of these nodes are. So here you have the life expectancy module. It's connected to these mortality rate modules. But if you look at this, these mortality rates are actually aggregates. So they're looking at a kind of demographic tranche of mortality rates. In order to presumably reflect the reality and make the simulation map the kind of real dynamics of the world, we would need to at least segment by individual ages, right? If not also account for where in the world people are living. So maybe include also country and age, and eventually get to increasing specificity, maybe even get down to individual people and have simulations that include individual agents, and who knows, maybe even go deeper into the biochemistry of individual people to try to understand their specific mortality predictions. And here we go. So this is the Roche biochemical pathways developed by Dr. Gerhard Michel. He started this project in the 1960s, and it was meant to provide an overview of the chemical reactions of cells in various species and organs, so including the human body. So it's an attempt to map out all the possible metabolic interactions. And over decades, he added more and more detail, more enzymes, more reactions. None of this means anything to me. Don't worry. But it eventually split into 2 separate wall charts because there's so much detail. And it's kind of, again, an amazing triumph of human ability to be able to map out all of this complexity and all of these different components and their interactions. And so presumably you could even go deeper into 2-oxoglutarate and understand and describe what its atomic structure is, and maybe even get down to the quantum level and then work all the way back up and have a more accurate map, right? So it's a kind of never-ending fantasy of total knowledge. Map it all.
Yeah, welcome to your...
I jumped into the however section.
Yeah, welcome to your design lecture. So the however for this, Christian was sort of alluding to it, but one of the things to remember is that these systems are based on an observation of something very complex and a willingness to map it. That mapping takes time. And what they do is they study the complex system as a fixed truth, a stable mathematical model. And if we know anything about the world, particularly the world of living things, the world is all variables. There are very, very few constants. Things are constantly in flux. There's no way you can say, hey, freeze, I'm mapping this. Like, stuff is changing all the time. This is no more visible, perhaps, than in economic systems. So in systems built on growth and capitalist systems, the notion of growth is at odds with the notion of stability. You can't say, hey, freeze everyone, I'm trying to map this. This thing is just moving all the time. So it doesn't freeze long enough for you to accurately map it and create a simulation. And the documentarian Adam Curtis, in his piece, All Watched Over by Machines of Loving Grace, which I encourage you to all watch, said the dream of the self-organizing system is a strange machine fantasy of nature. And the key point there is it's a machine fantasy. It goes all the way back to cybernetics and Arthur Tansley even, and thinking about the mathematical way that we do things. And it relies on mathematical models of equations and flow and feedback to make sense of things that actually may not exhibit that stuff. The second thing that's important there, and again, Christian was zooming in and explaining this, is knowing the scale you're working at for your map of a system and knowing where the edges are for you is really important. You know, you could say, I'm going to start looking at animals, and you could focus just on the microbiome on the back of a dung beetle and go really deep into that. Or you could say the Pacific Ocean. They're both valid in this space. And in the background of this is a piece you might be familiar with. There's a lot of Eames in this deck. God bless them. But this is the Power of 10 movie from the Eames, where they gradually zoom out from a molecular level all the way to a galactic level. But the philosopher Bruno Latour recently penned? Reasonably recently.
Recently-ish. Yeah, I don't remember.
OK. This millennia?
Sure.
Sure.
Yeah. All for Elias and things.
Sure.
Yeah.
Oh, yeah.
Continue.
Cool. So he penned a piece called Anti-Zoom, which is this notion we're very comfortable with zoom, in that I zoom in to a map, for example, and I zoom out. And the inference there is that the stuff when you zoom in, when you zoom out, it's still there. But the truth is it's not. It's different images. It's different content. It's from a different server. It's actually not represented when you zoom out, the stuff that you have when you zoom in. So this in itself is a world. This exists. But if we zoom out, it doesn't mean that all that information is still there, because in a very literal sense, there's less pixels defining that stuff that we've moved away from. This is also another world. This is also another world. And you know, there's been a few people who've played with this over time, but Lewis Carroll, the sort of comedic writer of Alice in Wonderland, wrote this really lovely piece in his book Sylvie and Bruno Concluded in 1893, which is the only way you can make an accurate map of the world is to make it one-to-one. But as soon as you make it one-to-one, you can't unfold it because it covers the Earth. This was also followed up by Borges and other people like that. But this idea of accuracy and zooming and the level to which you want to try and get as much accuracy and find the edges of your system means that trying to map everything and create a simulation becomes very, very difficult. And again, when you start to think about making a model of something and being like, I'm fine with the model, now we're going to turn it into a simulation, just knowing that you've missed a ton of detail is really important, because your simulation is going to lack that core information. And the more you zoom out and the more basic you make your model, the worse your simulation becomes. So you start to drift away from the ground truth of what you're actually trying to map. And Baudrillard, who's very French in this picture, coined this term, use this term simulacra, which is like you think you're building a simulation of a system or a model of how something works, but you've drifted so far away from the truth and left out so much detail that actually you're working in a parallel universe. The simulation that you're making isn't actually reflected in a ground truth of any sort. So those are three of the sort of tactics that people have used across design, but other things, other areas, economics and philosophy and politics, to sort of explore and make sense of mess. So let's take a quick flashback to design. Whew, there's Pantone chips. I think if we're really honest, and I want us all to be honest, I'm assuming there's quite a few designers in the room. It's a fair assumption. We still are stuck in a world where we lionize the individual designer. I think the UX community is actually ahead here. Like there's a general belief that UX is a team sport and it relies on engineering, it relies on product, and we work sort of collaboratively in that space. But certainly in architecture, certainly in industrial design, certainly in product and furniture, the cult of the celebrity, the cult of the individual, that sort of ignore the mess and I'm just going to make this beautiful thing. And we're not going to talk about the supply chains and all of the difficult stuff that goes with it and all of the implications that it brings with it. Likewise with products. You know, there's no surprise this is rendered in just a white space. It willfully ignores all the externalities. We judge design in a vacuum. We don't talk about all of the stuff that I showed you in that anatomy of an AI system is not rendered here. It's not discussed. It's not part of the conversation. We sort of rarely expose the underlying systems that go into making these things good or bad products. Design is still stuck in this loop of solutionism. We sell design as a tool to achieve utopia regularly, still. We still see launch videos where there's a happy family and some ukulele making everyone feel like, oh, if I just buy this thing, it's all fixed. We know that not to be true. We like this really clean message of like, just do the design and finish it and then everything's solved. We know that's not the case. Why do we still do it? There's huge momentum still behind these simplified models of design. This is, hopefully you know, David Kelly, one of the sort of founders of IDEO and the driving force behind the movement behind design thinking, and recently won the Bernard M. Gordon Prize from the National Academy of Engineering, which carries a cool $500,000 prize. So we're still really into this stuff. We still think it's all like what we should be doing as designers, but we've already seen those models when you actually try to use them, they don't really work. They don't really reflect the complexities of our discipline. Designers too, they're pretty sort of introspective. We have design Twitter, that's a thing. We talk to each other. We don't talk to other teams, other people, other disciplines, get their points of view. We rarely do that. I don't want to tarnish everyone here with the same brush. I'm sure there's scales, but we like to argue about Figma plugins and scroll bar designs, and we just sort of navel gaze and talk to ourselves. We're naturally introspective in that regard. And there are some people who are trying to engage with the deeper implications of the work that we do, but it's a little trite, you know, with a few notable exceptions. People sort of playing at ethics a little bit. It can often be, you know, I'm being a bit critical here, but it can be a little laughable sometimes, how we sort of portray ourselves as the arbiters of the ethical viewpoint, and yet there's professionals who exist who we just don't engage with.
So there's this kind of overwhelming feeling that we're just kind of spinning in circles as a discipline and not making a whole lot of progress on these really grand challenges that we talked about up front. And so this kind of general feeling of stasis amidst calamity kind of persists, right? So there's this great term, the dithering, that comes from Kim Stanley Robinson, who's a science fiction author. So this is actually from the perspective of a fictional society in the future, saying what this period of human history looked like. And it's described as the dithering, which is a state of indecisive agitation. Doesn't that kind of feel true about 2020? This is our colleague, Obi Felton, and I've always loved this quote. This is, she says that what has changed during our lifetime is the pace of innovation. So technological development now outpaces our ability to adapt to it, which has caused a kind of flare in our anxiety about technology and its impact. So this anxiety comes from technology outpacing our ability to understand it. And I think there's some reality to this. So these are, I don't know if you've seen this chart, but this is the technology adoption curves. And you can see that life actually is speeding up. So as things are more and more vertical, they're being adopted more quickly into society. So we're building platforms on top of platforms on top of platforms, and machine learning moves faster than software. Software moves faster than hardware. Hardware moves faster than infrastructure and landlines and yeah, all of the rest of that stuff that we had to do in the 19th century. And so it's no surprise that our response to VUCA is Marie Kondo. You know, like reduce the messiness, manage the messiness, kind of control and clean up a kind of messy experience of life. We retreat to self-care and mindfulness apps. It's a kind of willful ignorance, blocking out the noise, kind of retreating to introspection and introversion, just like get the mess away and give me a break from it, you know? So I think some of this is metaphorical, some of it is literal. I mean, at the end of the day, we're really hoping that together we can start to have a conversation about what a new disposition for design would look like that actually addresses, you know, the quote-unquote mess. So this is Paola Antonelli, and she advocates for design's new role as society's new pragmatic intellectuals. So changing from form givers to fundamental interpreters of an extraordinarily dynamic reality. So we need to find meaningful ways to fold complexity and messiness into our practice, and find ways to embrace messiness rather than try to manage it or simplify it. And we have 4 things that we'd like to see more of.
Okay. The first thing that we'd love to see more of in an emerging discipline of design and a disposition towards design work is we want people who consider themselves designers to be more exploratory and more critical. We think like the work of the radical designers of the 60s obviously had some flaws, but we think there's some tendencies in there that we really want to keep up and, you know, refresh in our discourse and in our practice. We want to consider more radical alternatives to our current paradigms. And this begins with starting to widen our reading circle. And again, I'm not trying to judge the people in the room, but I want us to get out of just checking Dribble every morning. I want us to start reading books that are on the fringes of what we consider to be design. Books about the future of the world, the future of technology, the future of society. Start to really think about our roles as the creators of things and products and services that are going to change the lives of people and the responsibility that comes with that. Anab Jain, who we really admire, has a lovely phrase, we're constantly looking out for weak signals, those murmurs of future potential. That should be our job. We're making things as designers and creators that are going to be out in the future world. And if we're going to be smart about it, we should be projecting. We should be spending our time thinking about the future, observing the future, and trying to make sense of the future. Speaking of Anab, her company Superflux recently did this project called the Mitigation of Shock, which was redesigning a city in the wake of significant climate change. And we use it here more as a, not necessarily to say focus on this project, but speculative design as a discipline is something I believe strongly in, as Christian does, but it has a tendency to find itself wallowing around in the shallow waters of the gallery space and the art space. We need to bring speculative and critical design into our core practice. It can't be something that's just something you do on the weekend at the MoMA. It has to be part of what we do as designers. We have to become critical. We have to move our mindset away from applications. I'm not talking apps, I'm talking about the applications of technologies and the applications of new things, and start really thinking about the implications of them. It's a responsibility that we have. We can't keep drawing these little simplified lines around ourselves saying, oh, not my problem, I'm the designer, don't come to me. It's our job. We're really good at helping people see those implications too. We have the skills, we have the ability to quickly make a film or quickly make a Photoshop of something and have people say, ah, I see what that is. Let's not do that. There's tools you can use too. So this is the futures wheel or the implications wheel by Jerome Glenn. It's just a simple diagram, your thing in the middle, but then have a ring of, in this case, 6 first-order implications. What might happen if we do this? What might happen if we finish this design and ship it? Second-order implications come beyond that. Once those first-order implications start happening to the world, then what? Just start thinking about then what? It's a really big part of what we do, and we have a responsibility to do that. Now, I understand, we come from a fairly privileged position that we're asked to think more expansively about our work. But we have challenges too. We work in an organization like many of you do. And this is a little tool that we've started to use occasionally, which is you can't just walk into a room and say, I'm not going to do your assets. I'm just going to talk about the political implications of what we're doing. That's not going to sit. But what you can do is break down your work. And so this is something that we use very sort of loosely and very occasionally, but we want to still be optimistic. And if a client, let's say, comes to us or a partner and says, I'm looking at doing this thing, yeah, let's go with that. Let's help you. Let's help you figure that out and do the 70% work, do the sort of optimistic work. But then there should be 20% of your time or your output or your work that's there to help them think a bit more, help them think about what they're doing and ask them questions that maybe they're not thinking about at the moment. And then maybe if you can really get on the right side of them, spend 10 minutes or 10% of your time really tearing it apart, thinking, how is this thing we think is good going to be terrible? How is it going to destroy something or a livelihood or something else? Think about the implications of what we're doing more. Spend physical time doing it. The second thing, so we said the 4. So anyone who's got dinner reservations, you've got an
almost
idea.
there.
Almost there. I'd like to see a break from solutionism. You might have gathered that from some of the things we were saying earlier. I think this idea that we've got this sort of technocratic optimism as designers, that we'll solve things, needs to go away. Please, no more of these sort of blindly utopian vision videos. Utopias don't exist. You know, we're living in 2020. I don't know how old all of you are, but the child in you thinks 2020 is going to be wild. We're still living with dongles. We're still living with all the problems that I mentioned earlier. Please, let's incorporate them, just as by means of a way of doing this. There's a project I did with the Near Future Laboratory, which is a small zine. I won't read it. But I wrote an essay in 2014 called The Future Mundane, which was a pragmatic framework about how we might design for the future in a very kind of down-to-earth way, to get away from those glossy touchscreen Minority Report vision video nonsense, and actually start to think about the future. And a way to think about the future, like I said, is backcast and think, what was it like in the 80s? What did we think 2020 would be like? So what we wanted to do in this piece of work was highlight the state of the world as it is, not in a kind of sneery, isn't the world rubbish way, but just, yes, we do live in incredible times with 3D printers and artificial organs and all this stuff, but we also have this kind of stuff. This is the world we live in. The world is partly broken, and it will continue to be. Now, most of the breakages here might not be particularly significant or have huge impact on people, but this is a familiar world. Yes, we've got Google Maps, and we've got all these services, and we've got all these tools, but they also have moments when they don't quite work for us. So I want us to really try and, as a discipline, and I say us because this is not us telling you what to do. I think we all feel a responsibility not to ignore this kind of solutionism. We need to get involved in solution entropy. We need to really think about the knock-on effects of what we're doing. We'll never solve things.
So 3 is that we'd like design to embrace plurality. So this is one of the core tenets of future studies, is that there are many possible futures. So Joseph Voros's 3 laws of futures are the future is not predetermined, it's not predictable, and it can be influenced by the choices that we make in the present. So there are many possible futures. We need to think about these plurality of outcomes that our design decisions could bring about. So not the future with a capital T and capital F, but many futures, just like bake that into the way that you say futures now. This is the futures cone, also by Voros, which tries to kind of describe different potential trajectories of the future. So you have the kind of general space of what's possible in the future. We also have plausible futures, possible futures, and critically preferable futures, which is ideally what we should be kind of steering or I guess society towards through our product decisions. But in order to consider a real plurality of futures, we also need a plurality of viewpoints. So I think everyone should agree with, but as a discipline, I think we need to be much better about including other perspectives. So women, people of color, different cultures, but also different attitudes and political viewpoints, different perspectives about the future. Pessimists and optimists sitting in a room trying to hash things out, because at the end of the day, we're all in this together, and we all need to make this work. And if you look back at, I think a lot of the examples in our deck, these kind of lionized heroes of design are generally speaking male, Western, and white. And I think that's a problem. We need to find meaningful ways to celebrate other voices in our work. So 4, we would like design to move beyond user-centered design and expand a kind of, and accept a kind of expanded scope of responsibility. So this, again, is Paolo Antonelli saying that all design is human-centered in that it touches everything but only cares about one thing, humans. So in this framing, human-centered design is kind of an insult. It's not enough. It's part of what leads to some of these the problems that we're talking about. So this is Kenneth Boll's diagram. And just to quickly, I know there's a lot of stuff here, but there are two axes, so actors and time. And you can see that in this framing, the traditional scope of human-centered design or user-centered design, as he puts it, is actually quite limited. And so he argues for an expanded scope of responsibility for the designer that includes not just the immediate decisions in the product that's for a particular user or group of users for a limited scope of time, but to actually embrace the externalities and unintended consequences of your decisions. And that's because our decisions don't just affect us. They don't just affect our products. They don't just affect the immediate users of our products. They affect all of us. And furthermore, we need to develop our ability to think more contextually. So design a thing by considering it in its next larger context. But I think we need to extend this ethos to include many more dimensions of caring beyond just your immediate scope. So it's not just about expanding in scale. It's also to consider the kind of many entangled effects of the decisions that we make. And then finally, to think in larger timescales than we're used to. So consider the layered forces of change that are at play and consider how your designs are situated within these forces. And I will hand it over to you, sir.
Ooh. 7 slides left.
Almost there.
Each one has 100,000 words on. No. We started this off, and I gave you a small inkling of what I think the world is and why I think the world is messy, and hopefully we sort of concur. But we need to think about where this is headed. Is the world going to continue to be messy? And in short, yes. Machine learning, you can't have gone anywhere without hearing about machine learning, but machine learning is ushering in an era where the tools that we're using cannot, with authority, be described accurately by the people who are creating the tools. GANs, convolutional neural networks, are immensely complicated things. And actually, the people who are creating them don't have the language properly to describe them to regular folks. And it's not just academic work. This is affecting music, it's affecting images, it's affecting video, products, and services. These are tools that are continually appearing in every product we use, and yet we don't have the language or the mental acuity to make sense of them. Secondly, we're entering a world of hyper-connected objects, so we're going to enter a world where there are new actors. These actors might not even be conversing directly with us, they might be conversing with each other. This is going to massively increase complexity. The world's going to be much more messy when we've got a billion things all talking to each other and we may be not able to understand, comprehend, or communicate with them. Furthermore, it's a bit of a played out example, but deepfakes is a good example to use here. The line between truth and reality, something we've held so true for so long as a way to make sense of a messy world. If we see something, then it must be true. That's also going away. There's a blurry line between what is real and what is not real. We're entering the era of synthetic realities, and that's going to make the world incredibly messy still. Not to mention the core fundamental that goes behind every app, everything you use, every light switch you touch is binary computing. We're entering an era now where we're entering the quantum age. Quantum computing is actually going to play with our notion of true and false, 1 and 0, on and off. Those concepts are amazingly difficult to understand. So all of this stuff is, if you're a designer, all of this stuff is coming into your world now and increasingly over time. It's going to get a lot messier. We're basically entering an era and an age of the hyperobject. Massively connected things living amongst systems and constructs that lie beyond the scope of what we as humans can understand and comprehend and communicate to each other. The VUCA that Christian talked about at the beginning, described in the 80s, relevant today, going to keep increasing. Design needs to find new tactics to deal with that and new approaches and new techniques to make sense of it. Because the future's coming, and honestly, we don't think design is very ready. So that's what we have for you tonight. Thank you very much.